Hello there Year 10, we are looking at our second distance learning lesson for this week, and last lesson we looked at the factors that affect biodiversity, and we talked about what biodiversity is, that variety of living things living in an area. We said variety was good because it's more likely to sustain a stable community whereby things rely on not just one food source but multiple food sources. Therefore, if one of those food sources is removed, they've still got a good chance of survival. So we looked at the factors that affect biodiversity, things like deforestation and making biofuels. Today we're looking at what can be done to maintain or even improve biodiversity. Okay, so we're looking at, okay, we've seen how biodiversity has been affected, and now what can we do to try and remedy that, to fix that, okay? So we have our title, make sure you write your date as well, biology books open, and the title is what can be done to maintain biodiversity. Today's lesson, nice quick one, 3 slides only. Okay, so we should get through this quite quickly because I do appreciate that last lesson was quite a big one. This is the last lesson in this topic for the combined scientists. That's the double scientists, okay? Still got a few more lessons to go for the triples, but combined, this is your last lesson on this topic. We will do some revision sheets like we normally do at the end of this topic. Once I finish teaching the triple content to the triple students, and then we'll all be in exactly the same place. Okay, so title, what can be done to maintain biodiversity? And moving on. So slide number 2 for today's lesson. We've got a graph here. The red dots show global population and the green line shows global carbon dioxide emissions. Okay, what I'd like you to do is, when we look at this in an exam scenario, we think about, is it describe the graph, which just says here's the pattern, or is it explain the graph, which is why has this occurred? Okay, today we've got describe and explain. Now you might want to either print this picture, you can find it on Google, or you could create a quick sketch graph which just shows you the pattern, or you can just describe and explain it. It's absolutely up to you. So we've got a scale on the left hand side, which is the carbon dioxide emissions. We've got a scale on the right hand side, which is the population growth. It's been very well manipulated, and that means that they have chosen very good scales to allow that data to sit on top of each other. So it's quite convincing in the way that it's displayed, to give us this idea that there is a very, very close correlation or relationship, I tried to them both, between these two sets of data. So we can see, we are going to write some of our own ideas here, but we can see that the global population is rising, and at the same time we've got the global carbon dioxide emissions also rising. Okay, that's describing the relationship. It's not saying why it might be like that. It's just saying this is what we see. Now, you might decide, and they like it in the exam, if you do decide to add some data. So you might say something like there was a steep incline between 1960 and 1980 or something like that, you know, where the global population and the carbon dioxide emissions increased a bit more steeply than they had prior to that event. So you could do something like that. So that's our kind of describe part of it. So we've said global population is increased. In line with that, the global carbon dioxide emissions have also increased. Now, the explain part of the graph, we'll be talking about, okay, well, what happens when global populations increase? We've got more people, therefore more respiration. Respiration produces carbon dioxide, so that's going to be emitted into the atmosphere. We've got more cars, because if there's more people, there's more likely to be more cars. We've got more industry and more power stations, usually burning fossil fuels. or biomass, and therefore releasing more carbon dioxide. We might have had a bit more deforestation to create space to put more houses. Okay, so think back to what we know about the carbon cycle, how that impacts it. This could then go on further and say, okay, well, what's the implication of this? And the implication could be linking it to greenhouse gases. Carbon dioxide is a greenhouse gas, traps that long wave radiation, and therefore heats up the planet. So we've got lots of kind of layers to this. We've got the describe the graph, we've got the explain the graph, and then we've got the implications of the impact of the graph, okay, and what that's showing us and how that could impact life on Earth, really. Okay, so have a go at doing the graph, just, you know, kind of get your own version of it, and then your describe and your explain separately. If you need extra time, then pause now. Okay, last slide for the lesson. So we're talking about, and this is straight from the course content, we are talking about what we can do to prevent biodiversity dropping even further, to keep that variety, to enable stable communities, and kind of make communities less vulnerable, okay? So we've got breeding programs for endangered species. This quite often will happen in zoos, where breeding programs exist, and then in some scenarios those animals are reintroduced back into the wild. Okay, so that's quite an easy one. We've got protection and regeneration of rare habitats. So this is where we protect areas, for example, the SSSIs, which you may have heard about in geography. And these are areas that are sites of special scientific interest. Okay, so they've actually protected the area and said no one can cut down these trees, you can't build on this land because we're going to protect this, we value this area, okay? And there's lots and lots of areas like that. The triple SIs are just an example of that, but we've got National Trust, we've got areas that are protected that we don't even realise are protected, okay? And regeneration, meaning that we're actually doing more planting, introducing new species into that area to try and build it back up again. Third point, we've got, and by the way, we are writing this list in our books, we've got reintroduction of field margins. Now, field margins, imagine a farmer's field, and you can actually, particularly if you've gone for a walk lately, you can walk around the edge of the field, and there's an area of the edge there called the margin, which might be between, say, 3 and 5 metres, where the farmer cannot spray any chemicals. So imagine there's fertilisers or pesticides or whatever being sprayed on the crop. They can't spray in that area, the margin around the edge, because if they did, and say there was a river nearby or another farmer's field, then when it rains, those chemicals could drain off and flow into those areas, okay? So the field margin is like a protective zone, so that when there are chemicals put on the land, if it does rain, then those chemicals just drain into the field margin. They don't actually go beyond that farmer's land. So reintroduction of those to ensure that there's that safety zone around different crops and areas that farmers use. Hedgerows, so putting lots of hedges around fields provides lots of environments for you know, small creatures and, you know, rodents and things like that to live in. And reintroduction of reduction of deforestation. So saying, okay, well, we can't cut down as many trees as we have. This used to be a massive problem, but now we've had things put in place over the last kind of 20 years. Deforestation isn't such a big deal, because when trees are cut down, they actually replace them with more than what they've cut down. So for every one that's cut down, they might put several back in its place, okay? So that enables that, again, linking back to the carbon cycle, removing that carbon dioxide from the atmosphere, okay? So reduction of deforestation, planting more trees, and then because we've got this huge population of people, recycling rather than dumping waste in landfill. So we've got recycle bins. My area's just had glass recycle bins delivered to them. Some places have that, some places don't. and it's about taking waste to the appropriate places, using it. We talked in a triple lesson a couple of weeks ago about the anaerobic digesters, getting the waste to the right places to enable us to make the most of it rather than just putting it in landfill, to reuse these resources as best we can to create as little waste as possible. Okay, so we need some notes on maintaining biodiversity. If you want to leave it there, by all means you can. If you want to do any further research on any of these, then you also can, but we've had quite a quick lesson there. Double science, we're now finished on this topic. You're going to do some extra revision on Educate, and then when we finish the topic, when I finish teaching the triples, we will then go back and we will do some revision for B7, and then we'll see where we get to after that. Okay, hope you're enjoying your day. Nice quick one. Glad the topic is finished for the doubles, not much further for the triples to go. Thank you.